All right, today's target will be evaluating functions. By the end of today's lesson, you will be able to use a function rule to evaluate a function when given an element in the domain. We will, of course, talk about what is a function rule. We'll define that for you. You will also be able to use a function rule to find elements in the range when given the domain of the function. So let's start by talking about function notation and the function rule. Uh, many functions have a rule that dictates how we connect an x value with a y value. We talked in the previous video about the requirements for a function, how a function can only happen when the x values don't repeat. But many functions actually have a rule that dictates how we map or how we connect an x value to a y value. That function rule is often written as an equation. For example, it might say the function rule might be that we multiply x by 2 and then subtract 5 to get the y value. Now when we write that, we use what's called function notation. Okay, and function notation looks like this. What that means, what that represents, is that this is a function of x, or f of x. A function f where x is our input. Okay, so what this f stands for, what this represents, this is just how we name our function. It's often written as f of x because f is the first letter in function, but you also will see g of x or h of x or a of x. It can be any variable, it's just basically the name of the function. And then what goes inside, this is the input. So this x, when normally it's x is when x is our default domain variable. It's the input to the function. It's whatever we're putting into the equation to get an output. Okay, so that's what a function rule is, what function notation is. Let's look at an actual example of a function rule. Okay, so this is a function rule. Okay, as an example, this is a function rule. This is an equation that tells us how to get from x to y. This is our notation. Remember, this is f of x. It's not telling you to multiply f times x. It's just notation saying f of x. Okay. So one of the things, our main goal for today's lesson is how do we evaluate a function given an element in the domain. Okay, so for example, we might want to evaluate this function when x equals 3. Okay. So what we're going to do is we're going to go back to our function rule and our function notation, and everywhere we see an x, we're going to replace it with the value of 3. Okay, so everywhere we see an x, we're going to replace it with 3. Even right here. So what that's doing, this is telling us, or telling the reader, that I've got a function f, and I'm putting in 3 for my x values. So I'm going to go over here, and everywhere I see an x, I'm going to put in a 3. Okay. So then all we have to do is simplify the right side. Okay. So 3 squared is 9. 3 times 3 is also 9. So my function value when x is 3 gives me 0. Okay. So what that means is that 3 is paired, 3 is an x value, and it's paired with 0 as a y value. So we could then write this as 3 comma 0. That would be a point, or that would be an element of our function. We could also evaluate this for, let's do another example. Let's say we want to evaluate it when x equals -2. Okay? So we're going to use that function rule, f of -2. So that means we're plugging -2 now everywhere we see an x. So -2 goes there, -2 squared minus 3 times -2. So once again, we've changed our x value. So everywhere we see an x, we're going to plug in a value of -2. So -2 squared is a positive 4. -3 times -2 is a positive 6. So f of -2 gives us 10. So what this means is if I plug -2 into my function, I get an output value of 10. So this point would be -2, comma 10. So that's how we evaluate a function given an element in the domain. Next up, we also need to be able to find the range of a function when given the domain. So when you're asked to do this, you will be given two things. Number one, you will be given the function rule. Okay? And then number two, you will be given the domain values. Okay? So here we have a function rule. Our function rule is 1/2 x minus 5. And our domain values, remember, domain is x values, but it also encompasses all possible x values. So what I'm telling you here is that the only possible x values for this function are 0, 2, and 4. And what this means is you have to evaluate the function for each one of these domain values. So I'm going to go here. I'm going to start with 0. So I'm going to plug in 0 for x. So 1/2 times 0 minus 5. So that is 0 minus 5, or just -5. So f of 0 is -5. That's my first range value. Okay? And then I need to do it for a positive 2. So f of 2 is 1/2 times 2 minus 5. Well, 1/2 times 2 is 1. 1 minus 5 is -4. So my second range value is -4. Now we're going to do it one more time for our last domain value. So 1/2 times 4 minus 5. 1/2 times 4 is 2. 2 minus 5 is -3. So my function value at 4 is equal to -3. So that is my last range value. Okay. So here we have 3 domain values. So we found 3 range values. Now it's asking us to write the range. Okay. So we can't just stop there. We have to actually write out the range like we did in class. Okay. So the range values, remember, you always want to write them in numerical order, and you do not want to skip values. Now, nicely enough here, they're already in numerical order for us. There's nothing we have to switch around, and there's nothing being repeated. So our 3 range values are -5, -4, and -3. So there is our range based off the domain we were given. Okay. All right, so those were our 2 goals. We talked about both of them. If there's something you didn't understand, please make a note of it, ask about it in class, rewatch the video if you need to. But now it's your turn to try. So I want to know what's the range of the function f of x equals 2x plus 1. So I've given you the function rule. And I've given you the domain of -1, +1, and 4. Okay? So what you're going to do is you're going to use that domain to solve for the range values, and then you're going to write the range values with the proper notation. So pause the video now. When you're finished, unpause it, check your work. So here we have it. We have evaluated the function for each element in the domain. We evaluated it at -1. We evaluated it at +1. And we evaluated it at +4. So we got from each of those values, we got a different y values. We got -1, 3, and 9, so which then we wrote with the proper range notation. So the range values here would be -1, +3, +9. Once again, rewind the video if you need to. Go back and rewatch sections if you didn't understand. Please make a note of it. Remember to ask that question when we get into class tomorrow.